Hi everyone, welcome to this lecture. So in this lecture, we will discuss what are the limitations of regression model and why we cannot use our regression model to perform classification and why we need logistic regression. So this is the regression line. So we have studied this regression and this is a perfect regression line or regression model because it is predicting all the target values very well. And here there is no loss or there is no error. So here the predicted values and the target values are equal. So there is no error. In this line, we can see that the target values and the predicted values are not same everywhere. So we need to calculate the error. But before error, we can see that this is the equation of regression. This is called the standard equation of the regression. So this is our target value and this is the predicted value. So when the target and the predicted values are equal, there is no error. Otherwise, we have to calculate the error. So what are the limitations of this regression model and why we cannot use it for the classification? So consider this data set. We have a data set where disease depend upon the age. So this is our feature and this is our output variable, which is discrete. That is whether a person has a disease or it doesn't has a disease. So these are the samples. These are our data samples or these are those patients who do not have the disease and these are those patients who have the disease. So this disease depends upon the age. So we can see that for those points where the age is high. So if the age is high, it means that patient is more likely to have a disease. If we see here, these are the low age values. So if the age is low or less, it means those patients do not have a disease or they are less likely to have a disease. So this is a data set of a disease where the categories are yes and no. That is, they are discrete categories, or we can see that we will assign 1 to the yes and 0 to the no. So they are logical categories. Now, what happens if we want to classify this data with the help of a straight line? So this is our straight line. Now we can see that this straight line is starting and it is extended from here. And we know that if we know the slope of a regression line or our regression model, we can extend our regression line from minus infinite to plus infinite. Now, what is happening here? So this is our threshold. So any point whose probability will be greater than 0.5 or equal to or greater than 0.5, we will say that it belongs to class 1, that is, it has a disease. And if any of the sample will have probability less than 0.5, then it will belong to class 0. So see how this line or a regression model is trying to perform the classification and where is the problem. So this is our threshold value. Now let's see this point. If I move this point or if I draw a straight line from this point to my regression model and then I calculate the probability, I can see that it is less than 0.5. Therefore, this point belongs to class 0. It means this line has correctly classified this point. Similarly, for all these points, this line will work better and it will correctly classify. On the other hand, if I see these few points, their probability will be greater than 0.5 and they belong to class 1. So for these few points and for these few points, this regression line is performing well and it is classifying correctly. But about this point and this point, it is doing misclassification. Because if I draw a straight line from this point or this data sample, this regression model is saying that its probability is greater than 0.5. Therefore, this should belong to class 1. So here is the misclassification because the actual label of this data sample is 0 and according to regression model, it should belong to class 1. So here is the misclassification. So what is happening now here? We can see that around 50% this line is doing well. That is the accuracy of this regression model is 50% when we are using it for the classification. It is performing 50% correct classification and 50% approximately misclassification. Now the real problem comes here when the line is extended beyond this 1 and it is extended before 0 on this side. Now what is happening over here? What about this point? If I want to calculate the probability of this point with respect to my regression model, then if I draw a straight line from this point to the regression model, then my regression model is saying that its probability is greater than 1. Similarly, if I draw a straight line from this point to my regression model, then my regression model is saying that its probability is less than 0. We know that probability cannot be less than 0 and probability cannot be greater than 1. So here comes the problem with the regression model, that it is not giving us the correct values of the probability. And we know that the logistic regression is a probabilistic classifier. So we cannot get probabilistic classification from the regression model because it can assign the value of probability greater than 1 to a data sample, and also it can assign a value of probability less than 0 to the data sample. So for these 3 data sample, this regression model will assign the negative probability, and for these 2 data sample, it will assign the probability which is greater than 1. So that is the problem with the regression model, and that is the limitation of the regression model, that it may classify few point correctly and few point wrongly. But the actual problem is that it is not giving us the correct value of the probability about the membership of the data sample. So what is the solution? Now the solution, one of the solution may be to change the slope or to change the angle of this regression line. Now, if I use this line, it seems that this line is a bit better line than this, but the problem is the same. Even its classification performance is better. It will classify more point correctly as compared to this old red line. But again, the problem is same. If I have a point here, in that case, if I draw a straight line from this point to my regression model, again, I am getting the probability value which is greater than 1, so which cannot be accepted. So the problem is, whatever be the slope and whatever be the direction of the regression model, there will be points in a data set for which the regression model will not produce the value of probability that should be between 0 and 1. So it means the regression model is not giving us the true values of the probability for all the data points. Therefore, this regression model is not a probabilistic model. So here is the solution. So we need a model like this to define the probabilities of a class membership. We need a model which should not go beyond 1 or which should not go below 0. So we need a model like this. This is a solution. Since this is not related to the linear regression model, we can see that it has 3 different values of a slope. It is a slope here, then the slope here, and the slope here. So it has 3 different values of a slope. So this straight line from start to end is not our linear regression model. So this is the solution of the problem, and this line is not a linear regression model. Therefore, we need to use another model, which is a logistic regression. So we see how logistic regression can use this type of a model in order to solve the problem of probabilities. So in this lecture, we learn about the limitations of the regression model. We see that regression model can perform classification up to some extent, but it cannot return the probability of every data point between 0 and 1. On the other hand, we need this kind of model which should not go beyond 1 and it should not go before 0. So this kind of model we need to adopt, and we see how this kind of model fulfills the requirement of logistic regression. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.